Hi there. Today we will be talking to you about interactions in physics. In physics, forces are labeled with a capital F and are characterized by interactions of two objects.
There are the 7 types of forces. The first one is applied force. As the name states, an applied force is the force that is induced on a desk by a person or another item. For example, if a person is pushing a desk across the room, there is a force exerted by the person on the desk.
Normal force is always presented when something is resting on a surface. If a book is resting on the desk, then the desk is making an upward force on the book. Remember, the normal force is always perpendicular to the surface.
The next force is friction force. The friction force is the force exerted by the surface when something is pushed across it. For example, if a book is being moved across a desk, the desk exerts a friction force. The friction force is always the opposite in which the book is moving.
Tension force is present when a box like this one is hanging from a string, rope, or wire. This force is transmitted through the string and is pulled tight from the forces on each end.
Next is air resistance. Air resistance, also called drag force, is a force that acts upon raindrops as they fall through the air. Like tension force, the air resistance is always opposite from the motion. When it rains, the raindrops fall to the ground, but air resistance is pushing up on the drop of water.
Gravitational force is always present. This is when the Earth, Moon, or other massive planet pulls items towards it from gravity. It is motion downward, and the gravitational force is equal to the weight.
Lastly, we have spring force. Spring force is the force exerted when a string or elastic material pushes or pulls a cube attached to it. For example, when a ball is attached to a spring, the metal spring exerts a force on the ball.
Have you ever wondered about the difference between mass and weight? Mass is the quantitative measure of inertia, measured in kilograms. The weight of an object is a gravitational force with which the Earth attracts the body. A weight, a vector measure, is different from mass, which is a scalar measure. The weight of a body is different based on its location near the Earth or another planet, whereas mass is the same everywhere in the universe. The weight of a body is the force that causes it to be accelerated downward with the acceleration of gravity, which is 10 meters per second squared. An example is the fact that an astronaut's weight on the moon will be much less, but his mass would stay the same.
Now that we know about forces, let's talk about net forces. The net force is the sum of all forces acting upon an object. It's written as sigma F, where the sigma represents the sum F and the F stands for force.
Along with net forces, we can also talk about Newton's first law. An object at rest tends to stay at rest, and an object in motion tends to stay in motion with the same speed.
For example, if we have this scenario, we can find the net force. If an apple is pushed to the left with a constant velocity, you draw a free body diagram and net force equation. So here we have a full body diagram, and we can see that we have 4 forces: gravitational, normal, applied, and friction. Our net force equation would be net force equals applied force minus friction force equals 0. Now, Newton also had a second law, which says this: for a certain force, the acceleration of an object is directly proportional to the net force and inversely proportional to the mass of the object. Basically, the forces are not balanced. A certain scenario could be this: if a flat cart is pulled at a constant speed but then is speeding up, the acceleration will be the same as the net force applied on it, but if we add weight to the cart, then the mass increases, causing the acceleration to decrease. This is the equation we should use, and as it speeds up, the acceleration force becomes larger.
Lastly, Newton decided to make a third law. This law states that when one object exerts a force on another, the second object exerts on the first and in the opposite direction. And so, they are equal to each other. For example, a bird is sitting on a branch. While looking at this, we know the branch is pushing up on the bird, and the bird is pushing down on the branch. Therefore, the bird pushing on the branch is the action force, and the branch pushing up is the reaction force.
Another example is a cat swats a toy. The cat's paw hits the ball, sending it right, and the ball hits the cat's paw. The cat's paw is the action force, and the ball hitting its paw is the reaction force.
Congratulations! Now you know about Newton's laws, net forces, and forces. We hope that you found this video helpful. Thanks for watching.